there, and welcome back to Inca High School Chemistry. This is Unit 2. We're looking at matter, its properties, its changes, and its classification. Beginning with Part 1 on properties. Now, every substance has its own unique set of physical and chemical properties. Properties are ways of describing it, its characteristics, and observations of properties can be variable depending on the conditions of the environment. Sometimes we talk about the properties of physical state, for instance, and at different temperatures, the substance may be a solid, or it may be a liquid or a gas. So it is important to specify the conditions at which the observations are made. Conditions of temperature and pressure, for example. And that's because both chemical and physical properties can be dependent on temperature and pressure. Now, physical properties are characteristics that a sample of matter exhibits without any change in its identity. For instance, whether or not it will dissolve in water is a physical property of it, because if it will dissolve or not, of course, as an identifier, but it is physical rather than chemical, because it's easy to get that sample of matter back just like it was. You can just remove the water and get your salt back like you had it. Physical properties are things like if it's brittle, if it has luster, if it will conduct electricity, what state it's in at room temperature, and so forth. Physical properties can be observed without any change to the identity of the material. When we observe it, we can observe it with our senses. So we're looking at it, we're smelling it, how it feels, its texture, its taste, although that's not a good observation to make in the lab. Observations can also be not only qualitative like that, but also quantitative. We measure its mass and volume and density and so forth. So you got to remember that it can be observed or measured without changing the sample's composition, its identity, what it's made of. And physical properties are useful for describing pure substances. That's because pure substances are going to have uniform, unchanging compositions, so they'll have uniform and consistent, unchanging physical properties. Mixtures, on the other hand, since they are made in varying compositions, varying proportions, will have varying physical properties. Physical properties are going to be such things as solubility, color, density, odor, melting point, boiling point, taste, hardness, electrical conductivity, physical states, such as whether it's a solid, liquid, or gas, luster, malleability, ductility. All of those are physical properties because they can all be observed without changing the material into something else. And these are identifying characteristics of a substance. When you're trying to decide what substance you have, you're going to look at these physical properties as well as chemical ones. Now, physical properties can be described as being one of two types. They can either be extensive, and extensive properties are dependent upon the amount of substances present. For instance, the mass, the length, the volume. Those are extensive properties. But they can also be intensive properties, such as the density. Density is the same regardless of whether you have a small sample or a large sample. So it really doesn't matter how much you have. So it's independent of the amount of substance that's present. Besides physical properties, there are also chemical properties. Chemical properties are those that can be observed only when there's a change in the composition of the substance. In other words, when you change it into something else, when you react it with something else to form a new compound, to form a new substance. For instance, the ability of iron to form rust is an example of a chemical property of iron. The density of iron is a physical property. But not only is the ability to react a chemical property, but the inability to react is also a chemical property, because it tells how it doesn't want to react with another substance. For example, when iron is placed in nitrogen gas at room temperature, no chemical change occurs. So the fact that iron is unreactive in the presence of nitrogen is a chemical property of iron. Now, one property of matter is whether or not it's a solid, liquid, or gas. And of course we have to specify at what temperature and pressure. There are three physical states of matter that exist generally on Earth. There is a fourth called plasma, but it's less familiar. We're going to be interested in this class in solid, liquid, or gas. Now, changes in physical state, changes from solid to liquid, or liquid to gas, or gas back to liquid, or liquid back to solid, don't change the substance into a new thing. For instance, when water freezes into ice, it's still H2O, so therefore its chemical composition has not changed. Its identity is the same. It can melt back to form water and still be H2O. You can boil water and turn it into steam, and it's still H2O. It's just in the gaseous or vapor state. And you can condense it back to get liquid water. So it's those changes are physical changes, and those states are its physical states. And physical state is a property of a substance. And here are your three common states of matter, and they can be distinguished by the way the particles will fill a container. For example, a solid is a form of matter that has its own definite shape and volume. That's because the particles of a solid are packed together so that the particles are touching, and they are arranged in a specific pattern that does not change. The particles are held in place. So when they're heated, a solid will expand, but only slightly, because as long as it's a solid, the particles are going to be held together. The shape is definite, so therefore it does not conform to the shape of the container in which it's placed. So unlike solids, liquids have an indefinite shape. That's because even though the particles are close together, they are not held rigidly in place, and they're not as tightly packed as the particles of solid. Liquid particles are able to move past each other. It's as if they are kind of like marbles in a jar. You know, you can kind of roll them around, and they roll past one another. So they will take the shape of their container and fill in the nooks and crannies, but they do have a constant volume. They don't expand and fly around to fill up the volume of the container. If particles of a liquid are like marbles in a jar, particles